This is section 4.1, and today we're going to start a whole chapter on triangles. And we're going to start off just by talking about the different types of triangles. So we can classify triangles. That means we can kind of categorize them or name them based on information about their sides and by their angles. So these are words you've already heard before. We're just kind of putting some fancy words around it, saying this is how you classify. So if you have three sides of a triangle where none of them are the same, so none of these are equal tick marks, so none of them are the same, that is called a scalene triangle. When two of the sides are the same, that is called isosceles. When all three sides are the same, that is called equilateral. And that actually is a word we did way back in chapter 1. By angles, when all of the angles are less than 90, that's called an acute triangle. When you have one 90-degree angle, that's called a right triangle. When you have one angle that's 120, not 120, anything over 90, then that is called an obtuse triangle. And the last one is if you have all of your angles that are equal, then this is called an equiangular. We also had that word in chapter 1. So those are the 7 different ways that you can classify a triangle based on either sides or angles. What you really have to watch for when you're doing the homework on the test is the information you're given. So if you're given information about the angles, make sure you pick an angle name. And if you're given information about sides, make sure you pick a sides name. Even if you can figure out from that one equilateral has to be equiangular, this is the information we knew. So equilateral would be what you would say. So triangle sum theorem, today we're going to talk about how the measures of the triangle, the measures of the angles, the sum of the angles of a triangle, I'm going to sneak it in here, equal 180. So if you add up all the angles in a triangle, you get 180 degrees. And I think you already knew that too. That's something you learned way before 10th grade geometry. But we're refreshing it here. We're going to use it today in our homework. Exterior angle theorem, this might be new to you. It says that the measure of an exterior angle, so one on the outside, is equal to the sum, that means addition, of the measures of the two non-adjacent, that means not touching, interior angles. Those are on the inside. So using this picture, I'll kind of give you an example. This angle 1 out here, that's on the outside of my triangle. So the measure of angle 1 is equal to the sum, that means add, of the two non-adjacent, so non-touching inside angles. Well, C touches angle 1, so it can't be that one. So it's got to be A plus B. So when you're looking at an angle on the outside, go all the way across the triangle to those two, and it's those two added up that equal that one. So we'll do a quick one like that, exterior angle. So the one on the outside equals, don't look at the one next to it, not an X. I should just like shade that. We're not going to use it. Go all the way across the triangle to these two, equals X plus 70. So I'm going to minus my X to the other side. And then I'm going to add 5. And this problem didn't just say solve for x, it said find the measure of JKM. So I'm going to trace from J to K to M. So we're talking about that one. So I'm going to do 2 times 75 minus 5. 2 times 75 is 150, and then minus 5 is 145 degrees. 3 more examples using either interior or that exterior rule. So interior, all the angles in a triangle add up to 180, so 2x, and we know that boxes are 90, and x minus 6 have to equal 180. So I'm going to put my like terms together. 90 minus 6 is 84. 3x equals, we're going to minus that 84 over, and then I'm going to divide by 3. I'm really trying to sneak this in here before I run out of paper. Looks like 32. Next picture, this one is on the outside, so that outside angle is equal to, scratch off the one next to it, go all the way across and point. Those are the two you're going to use. So the outside angle is equal to the two non-adjacent, not touching angles. So I'm going to minus 3x over. I'm going to add 10 to both sides. And then divide by 2. Alright, last one. A lot going on here. It's not a straightforward inside or outside problem. So I'm going to look first at looking for a piece of paper where I can cover up part of this triangle. There are a lot of mini triangles inside of here. I'm looking for one that's got the most amount of numbers in it. So when I look at this triangle, I've got a 32 up here, and a box right there, and a Y right there. X is not in a corner of the triangle, so when I trace that triangle, that's what I drew. So that X is like hanging out in the middle here, and that's not helpful to me. I need stuff in the corners for the angles. And I know that all that has to add up to 180, so 32 and my 90 box and Y has to equal 180. So I'm just going to take 180 and minus the 90 and minus 32. I'm going to get 58 for Y. I'm just going to kind of write that on top there so I don't forget. Okay, next triangle where I see there's a lot of stuff is this one. I'm just going to draw it right over here. So I've got a 58 right here. I've got a 27 right here. And I don't know this. I'll just put a Z there because I don't know what that is. It's not quite solving for my X, but remember my X is kind of, it's in the middle of this triangle, so not helpful. It's in the corner of this little tiny one, but we need a little bit more information because there's only two measures there, a 32 and an X, so it's not enough. So looking at this one, I still know that all my angles have to add to 180. So I'm going to take 180 and I'm going to subtract the 58 and the 27. I'll find out that my Z is 95. I'm going to put that right here so I don't forget. And now my X and my 95 make that rainbow that we've talked about before. They make a linear pair. So X plus 95 equals 180. So it's a three-step problem for us in order to get to just what X is going to be. We had to first figure out Y using a totally different triangle and then work our way over to X. And X is 85. So today you've got interior and exterior angles, how to find those measures, and then we've got all the different ways in which to classify a triangle.